So let's start with this item here. So at D, right? This is the last problem I have in multiplication of rational expression. The last item we have is the division of rational expression, and that's what we will focus in on today. But before we do that, if you were to see this problem on your homework, on your quizzes, on your tests, on your final exam, what do we do? Okay, so if the direction will tell you to multiply rational expression, and if you multiply rational expression, this is what you need to ask yourself is, just for me, I put number 1, number 2, number 3, number 4, just to tell me that I have 4 individual problems. Okay, so if they tell me to multiply rational expression, I say, okay, I have 4 individual problems. At number 1, what can I factor out? And hopefully by now, number 1, number 2, and number 3 is the easy problem. Okay, why is easy? Well, first of all, number 1 and number 2, there's no number in front of x squared. So that gives us an idea that we need to ask ourselves, is there 2 numbers multiplied to give me 56, but subtract to give me 1? So again, 2 numbers multiplied to give me 56, which is 8 times 7, or 7 times 8, subtract to give me 1, which is 8 minus 7 is 1. And in this case, the 8 is a negative because we take the sign of the larger number. And again, the middle number is negative, so the larger number will be negative. The other one will be opposite, which is positive. And at 2, we ask ourselves, is that 2 numbers multiplied to give me 64, but add together to give me a negative 16? And again, 8 times 8 is 64. 8 plus 8 will give me 16, but the 16 is negative. Again, in order for you to add, they have to have the same sign. So in this case, they will be both negative. They cannot cancel them out if they have the same sign. Same side we add, opposite side we subtract. And at 3, this is the easy problem because this is the only thing you factor out is the GCF, right? Even there's a square, I know the 4x squared is a perfect square, but the 3x is not a perfect square. So we cannot factor out a binomial, that perfect square binomial. The only thing they have in common is an x. 4x squared and the 3x, they have in common x. So the only thing I can take out is an x. Left me with 4x minus 3. Now, what do I have in 4? At 4, this is the hard problem. Why is hard? Because there is a number in front of 4. And if there's a number in front of 4, we know that we need to do the AC method or the try and error. If you know try and error, you can do try and error. But we do the AC method. We take the 4 times the 21. 4 times 21 to give me 84. Is there 2 numbers multiplied to give me 84, but subtract to give me 25? 28 times 3 is 84. 28 minus 3 is 25. So what do? I rewrite a problem. Instead of say 25x, I rewrite a problem and say 28 minus 3, because 28 minus 3 eventually will give me 25x. Once I rewrite the problem, I need to group them up. I put the 2 numbers in the first group, the second 2 numbers on the second group, and then I factor out a GCF. In the first group, I can take out a 4x. In the second group, because I include a negative, I need to factor out a negative 3. And again, I have 4x plus 7. X plus 7 is the common multiple or a common factor. I take out x plus 7, and the leftover will give me 4x minus 3. Okay, so once you have this thing here, the only thing we do is, again, at 1, we put in where the 1 location is at. The 2, we put in 2 location, and the 3, we put in 3, and the 4, we put in the 4 location. So again, the white item on the bottom is just basically, I factor each of them out. And once we did this thing here, and again, is like I mentioned the last time I met you guys, is tedious work, and one problem can take the whole page, and if you write big, probably 2 pages. But again, the work is not new, right? The work is just continuously of what we did in chapter 6. Now, what do we do? Again, the only thing we have in common, or not in common, now what can we cancel out. What do I have on top as on the bottom? So I can cancel that out. And again, x plus 7, I can cancel out. 4x minus 3, 4x minus 3, they can cancel out, which left me with x over x minus 8. And ladies and gentlemen, the reason why I give you, or I put x minus 8 in the parentheses, you don't have to. You don't have to, but the reason why I put it in parentheses is, remember, I mentioned this last time, is if you want to cancel anything out, if there is a binomial, make sure that if you cancel, you have to cancel the whole thing. For this thing here, we cannot pick and choose. We cannot say, oh, this x up here and this x down here, we can cancel them out. Reminder, in order for you to cancel out a binomial, in this case, this is your binomial x minus 8. In order for you to cancel out, you need to cancel out the whole thing. We cannot pick and choose and say, oh, let me just cancel out the x and not the 8. Or let me cancel out the 8, not the x. If you want to cancel the binomial like this right here, you have to have another exactly same item in terms of x minus 8, x minus 8, x plus 7, 4x minus 3, 4x minus 3. They cancel everything out. This right here, you cannot just cancel the x without a negative 8 or minus 8 here. So this is my answer, okay? This is the answer we have, or this is what we have in terms of chapter 7. So let's take a look at the second or the last item we have in 7.2, and then I will take any question you might have. So the last example we have in 7.2 is how can we divide and simplify rational expression. So if we have something like this, and this is what I want to point out to you guys is, example 2 is just the same as example 1. Multiplication and simplify rational expression is very identical to dividing and simplify rational expression. Why? Because if you remember your rule for divide fraction, if you remember your rule for divide rational number, we cannot divide rational number. What do we need to do? Well, we need to change the division to become a multiplication and take the reciprocal. Right? That's the rule that we have before. The rule that we have before is whenever we divide rational expression, whenever we divide a fraction, what we need to do is we need to change the operation from division to become a multiplication, and then flip the second fraction, or in this case, flip the second rational expression. So we change and we take the reciprocal. As you can see up here, this is what I have up here. I have x squared minus 121 over ax squared plus 32x. Now I need to change the division. The division need to change to multiplication, and that's what I did. I changed it to multiplication, and then I just take the reciprocal, or I need to flip the second parenthesis on, in this case, rational expression. Okay, so that's what we do. Those are the rules that we have before. The rule we have before is if we divide rational expression, we need to convert division to become a multiplication and take the reciprocal. So as you can see, have this problem. Is this problem different from this problem we have over here? Well, once you do the transformation, once you change the division to become multiplication, it's just exactly the same problem. And how do we multiply rational expression? Well, we can't. Well, we could, right? But instead of multiply them, what do we need to do? Well, we can factor them out, right? We do this thing here as before. We treat this when you see that we have multiplication, rational expression, we treat each of the item as one individual problem. We treat the numerator as one problem, the denominator as one problem, another problem, and that's where I told you guys that multiplication and division rational expression is just 4 individual factor problem double stack, right? It's just on top of each other. So at 1 here, hopefully you guys see very consistently kind of the same. All of this thing here is easy factor. This thing is easy because x squared minus 121 is easy because those are your perfect square. So number 4, hopefully right now you guys snap your finger and say, oh, Mr. Trang, I got number 4, x plus 11, x minus 11, right? At number 3 should be easy because again, even though there's a square, even though there's an 8 in front of x squared, but it's not a trinomial. So most likely we can factor out a GCF, right? So number 3 and number 4 should be easy. Those are the easy factor that binomial, you either factor out a GCF or they got to be a perfect square, subtraction of the perfect square right here, right? And number 1 and the number 2 is also easy because there's no number in front of x squared. By now, cross my finger that all of you guys know that all we need to do at 1 is there 2 number multiply to give me 7, subtract to give me 4. And this item, same idea, is there 2 number multiplied to give me 28, but add together to give me 11, okay? So again, if you look at this thing here, nothing new, right? Nothing new. At 1, what do we have? We know that 77, you have 77 times 1 and 7 times 11. Those are the only 2 number you can get to multiply to give you 7. And again, hopefully you guys see that 11 times 7, 11 times 7 is 7. 11 minus 7 will give me 4. And again, the 11 is bigger. So 11 will get the sign of the larger number. And at 2, hopefully you guys see that we have 4 times 7 to give me 28 and 4 plus 7 to give me 11. Right? And at 3, what is the GCF here? We know that there's an X in both of them. And what else? Well, 4 is good, but 8 is better, right? 8 is a common divider between 8 and 32, right? I can take out 4, you can take out 4, but 4 is not the greatest common factor. It's not the greatest number that can go into 8 and can go in 32, right? So in this case, this is what I have, which I can take out 8x, and on the bottom, like I mentioned, x plus 11, x minus 11, or x minus 11, x plus 11. And again, looking at this thing here, division or divide and rational expression is just take you or ask you to do one transformation. You need to translate transformation. You need to change the division to become a multiplication and flip the second item. And once you do that, everything should be the same as before. And once you factor them out, and like I mentioned, the only thing new is what can I cancel out? As you can see, x minus 11, they can cancel out. X plus 7 on top, x plus 7 on the bottom, they can cancel out. And again, for x plus 4 can cancel out. Therefore, my answer is ax over x plus 11. And again, let me ask you guys, first of all, let me ask you guys any question here with this example 2a. Now, let me ask you, see if you can do this problem for me. A little bit different, but not that big of a difference. Again, I ask you, see if you can do B, which, well, let me do the first step with you guys, and then I let you guys do the rest, right? So if you look at this thing here, if you see that we have a division, please do not jump the gun. I know division and multiplication are very close. For rational expression, it's very close. Make sure that you identify, circle this. You say, oh, it's a division. Trigger yourself that say, oh, this is division, so I need to do one item before I can factor. I know I need to factor, but I need to do one item, and that item is we need to convert this to multiplication. We need to convert to multiplication and take the reciprocal. As you can see, 2x squared minus x minus 45 is on the denominator. I flip them and it's become a numerator. Vice versa, this thing here is on the numerator, is now become a denominator. So again, that's what we need to do in order for you to derive rational expression. That's what you need to do, is you need to convert, we need to convert to multiplication and take the reciprocal. So see if you can simplify item here. See if you can simplify the 1 location, the 2 location, the 3 location, and the 4 location. And hopefully you guys see this right here, no trick, is a perfect square, ladies and gentlemen, is a perfect square. 4x squared minus 81 is a perfect square scenario. So see if you can factor all of this thing out. So if you factor them out, hopefully this is what you have. Again, at the location 1, hopefully you recognize that we have a binomial. And if we have a binomial, the only thing we ask ourselves is, again, is there a perfect square scenario or is there a GCF scenario? And in this case, hopefully you guys see that this is a GCF scenario between a 2x squared minus 9x. Again, I know the 9 is perfect square, but again, the 2 is not. So it's not fit the description of perfect square scenario, right? So again, and the 2 terms have an x, so they are not perfect square scenario. So the only thing we can do is a GCF. So if it's a GCF, what can we factor out? Hopefully you guys see that we can take out a 2, I mean not a 2, an x. And that left me with 2x minus 9 because x times x is x squared and x times 9 is 9x. So the only thing I can factor out at 1 is an x. There's nothing else, right? And at 2, hopefully now at 2, you guys see that this is a perfect square. And if this is a perfect square, what do we have? A perfect square, what do we have in terms of this thing here? Again, this is your perfect square scenario, and this is your perfect square scenario. So hopefully you guys see that the first item is 2x and the second item is 9, right? 2x times 2x and 9 times 9. So in this case, we have 2x plus 9, 2x minus 9. Okay. And one thing I want to show you guys or to say, most of the time, one or some of your factor will give you an idea of what the other item is. So if you stuck with 3, maybe you can do 4 first, and that should give you an idea of what the numerator is. But let's take a look at this thing here. And again, this one here, probably the hardest factor that you have is just that you know, it's a long item. We have this thing here. Because there's a number in front of x squared, we know that we need to do the AC method. And the AC method tell me that 2 times negative 45 will give me negative 90. And is there 2 numbers multiplied to give me negative 90, but subtract to give me 1? I have 10 and 9. So what do? I rewrite this problem in terms of 2x squared minus 10x plus 9x, because negative 10 plus 9 will give me negative 1 minus 45. I group them up. And again, in the first group, I can factor out 2x. That's left me with x minus 5. In the second group, because I include a positive, I need to take out positive 9. That give me x minus 5. And as you can see, this is what I have. Again, you can put x minus 5, 2x plus 9, or 2x plus 9, x minus 5 is up to you guys. And hopefully you guys see on the bottom 40 is that 2 number multiplied to give you 40, but add together to give you 13. Hopefully you guys see it 8 and 5. 8 times 5 is 40. 8 plus 5 is 13. And again, that's the hardest part, right? The hardest part is changing division to multiplication and take the reciprocal. And then, that's not hard. The harder part is factoring. And if you know how to factor, the new thing in chapter 7 is this. Literally, this is what they tell you is, what can you cancel out? Again, we know that 2x minus 9, 2x minus 9, 2x plus 9, 2x 9, and again, x minus 5, x minus 5. Literally, everything cancels out except the x on numerator and a x minus 8 on the denominator. Okay, so again, like I mentioned, in the earlier class, and I wasn't, try to sugarcoat anything. The hardest part of chapter 7 is the factoring problem. If you know how to factor, then this chapter is nothing new. Cancellation is probably the only thing new that you see. But first of all, looking at this thing here, question on any of this problem that I have, how I got the answer in terms of x over x minus 8, or any question in terms of any of this thing here, ladies and gentlemen. Well, if you don't have question, like I mentioned,